Good morning. I'm presenting my research on the defense in-depth security for banking loan system using the Python testbed for Neobank CAS. I will demonstrate how common web vulnerability threaten financial workflow and how layered control will provide effective protection. Last semester, Vietnam Credit Information Center or CIC suffered a major breach attack exposing sensitive financial data. This isn't just theoretical anymore; it's happening right now. And banking system like loan platform over here handle critical assets like platform, customer PII, credit score, income disclosure, and approval decision. So when compromised, the consequences are severe. It would be like identity theft, financial fraud, regulatory penalties, and even reputational damage. So my project here will address this real-world threat. So let's start with the SQL injection. I will log in over here as the branch one. So normally you see here, I only have 72 record. This branch isolate is crucial for banking privacy. So now let's watch what will happen if I exploit a search vulnerability. Reputation will be 72, but if I input this exploitation, you can see now it has been over 400 record, which is from all the branches. This single payload bypass the branch isolation and in real banking system. This expose the customer national ID, contact detail, income information, and a catastrophic confidential breach that will violate both privacy, regulation, and internal control. So you see, I am viewing my application. This is from my branch, right? If I change this to 300, remember that I'm in Ho Chi Minh branch, but now I can view the Sancha branch, which is just by simply change the ID over here. I now access the application from another branch. This is the horizontal privilege escalation. The attacker remains the same user, but illegally expand the access across organization boundary. And in banking, this violates the separation of duty and branch isolation requirement that regulators mandate. Next, will be the cross-site attack. I will create a new application. And here, I will leave the script for attack. Be the code for this one. So after I create application, the session will show this one. So cross-site scripting is represent a different level of threat vector. So here, after I create that, you can see that the script execute immediately when the application being created by any user role. So they will be stored in XSS. And even if the HTTP only cookies such as like script can, but still the script can still access to the sensitive data and display on the page or manipulate the interface element to influence decision. So I can show you this branch one. It's the one I just created over here. And yeah, the section of this user also be stolen as well. So next, I will demo for the command injection. We're talking a different layer. This the operating system. So I will log in as the Azure over here. Okay, I will get into the input side. So next, I will demo the IDOR attack. So as you see over here, my system detect the shell meta character, show that what would execute it. Yeah. So in a vulnerable system, Wormy would run and revealing the server count. Next would be the database dumped, backdoor, ransomware, import function, or partially dangerous because they often accessed by the privilege of role and execute with the high permission. So finally, it will be the session security. So attacker often combine the XSS weak section control. This one. So after this one, we have the session, the value, and everything over here. The domain path, the thing. So I'll copy the values and the session name, domain, localhost. We'll come to this side. It put the exact same one over here in this section. You see, I'm get inside this user without entering any password. The session token alone provides the full access, right? So this demonstrates the account takeover. The attacker can now perform any action with the victim code, like approve loan, modify decision, access to sensitive record, and industry report consistently show that credential and session abuse as the leading instruction vector for financial service. So this demonstrates showing how single control fail and banking security required defense in depth multiple independent layers so that bypassing one doesn't mean total compromise. Showing 5 essential layers: network protection, authentication section, authorization knowledge, input validation, and output encoding. Each layer will catch what the other might miss. So these fixes aren't complex, really. They're about the consistent secure coding practice. So we also apply the strike threat modeling systematically identify risks. So each map here, each attack map to specifically find the strike category across 4 binary. I have input the attack privacy. So SQL injection represent the tampering and information disclosure at the server database boundary. IDOR, in another hand, is the information disclosure and elevation of privilege and at the object layer. Whereas on another hand is the tampering enabling the information disclosure. Command injection is the tampering and elevation at the OS boundary. And session hijacking is spoofing and elevation at the client server boundary. So this whole structure analysis they ensure that our defense address both explorability and the impact. So I have linked here all the fixed code for the Python. If you apply this one to your website, it will work. So after implement this layer control, all 5 attack would fail. SQL injection would return only authorized data. Either attempt get 403 forbidden responses. XSS payload will render as a plain text. Command injection will be removed. Session hijacking fail with rotate token and hardened cookie. But importantly, the several attacks require multiple control, like session hijacking prevention need both cookie hardening and XSS elimination. So these interdependence validate defense in depth. Layer control provide resilience against both known attack and novel exploration path. So there are 3 insights emerged from this work. First, security failure in banking system really comes from single flaws. They change across the trust boundary. So requiring the comprehensive rather than the aspect control. Secondly, the defense in depth is essential because there's no single control is perfect. Okay, and layer create resilience. Third is a secure backing required, treating security as risk engineering. So it's not just the vulnerable patching; it's a mindset shift from fixing defect to building a defensive system under the constant change. Looking forward, we are expanding this work with structured audit logging, CI integrated security test, and AI assistant security consideration for next generation banking system. The Vietnam CIC system incident reminds us that the credit ecosystem remain high value target requiring continuously security evolution. Thank you for listening.